Now, further to explain you guys that other than gini impurity or gini impurity, we have other matrix also. One of them is known as entropy, which is the state of disorder or uncertainty. So whenever we will be building a decision tree, we can select which split criteria we want to use, whether the gini impurity or entropy or information gain. We can select either of these. Gini impurity, as I said, it should decrease as we go down the tree. Same is the case with entropy. What is entropy? Even in chemistry, we study entropy is the state of randomness or uncertainty of a system. So as our tree grows, our tree should be more and more confident in accurate predictions. It should not be uncertain, right? So that means if our tree is growing in depth, its entropy should decrease. It should become more and more certain in any prediction. If it is saying something, it should be becoming more and more confident. If I am saying this, I'm more confident, right? So that means even entropy should decrease. Information gain. What is information gain? Information gain, you can understand as in the knowledge which your tree is gaining as it is growing. So information gain should ideally increase. Okay, as the tree grows, information gain should increase. And information gain, guys, is derived from this formula, which is entropy of parent node minus entropy of child node. So let me explain you. Let's say this is how my tree is growing. So entropy E at this point, let's say, was 4, and entropy here was 3, and let's say entropy here was 2.1. So as we discussed, this is a correct tree because entropy is decreasing as we are going down, right? Entropy should decrease. But what is information gain, guys? Information gain, we don't have any information gain at the root node, but the information gain at this depth, right, at this layer, is entropy of the parent node, which is 4, minus entropy of this node, which is 3. So 4 minus 3 is equal to 1. So the information gain here is 1. But at this level, right, or this depth, the parent entropy is 3, and the layer, this level's entropy is 2.1. So if you subtract this, what is the value you are getting? 0.9. Okay, if you see, these are the formulas for the Gini impurity, for the entropy. Okay, as our model grow in more and more depth, its Gini or entropy should always decrease, but the information gain should increase. Okay, but now, as I told you, that there needs to be some stopping criteria, as in your model should not grow indefinitely, otherwise it will become overfit. So there are certain mechanisms implemented by the model itself based on which it can stop the growth of the tree. But if you want to explicitly stop the growth of the tree, you can decide max depth. So for example, you have, let's say, 100 features. So it is probable that this tree may try to grow till a depth of 90 and more, but you only want a tree which is, let's say, 10 level deep. So we start from here, first level, second level, third level, fourth level, fifth level, right? So you want a tree which is only deep till 10 levels. So you can specify a maximum depth parameter. Then there is minimum split, minimum bucket, minimum impurity decrease. These are different stopping criteria which we will see in the actual implementation program that we will be doing. See, so this is how the tree is plotted. This tree may not be that good in visualization, so I will plot it in a better way. But if you see, there is a root node where there must be some feature, so we need to check which feature was there. Then there is a feature here, there is a feature here. These two may be same feature, may not be. Okay. Then at this layer also we have certain splits. So this tree is growing, right? So here it is like depth 1, depth 2, depth 3, depth 4, depth 5. So after the root node, if we keep going down, this is the depth first. So root node is at the depth 0, you can say. So depth 0, depth 1, 2, 3, 4, 5. So 5 level deep tree it is, right? And one more important thing that you should know is that if a feature is already part of split at a particular level, it does not mean that it cannot take part in the split again. Means that same feature can be a part of the split again also, guys. Based on calculations, it can be there again in the tree. So don't think that if a tree has used a particular feature already, that feature is no more eligible for split. I have seen the case, let's say age less than 40 was here, but here again age was there and less than 20. So first based on age less than 40 you came here, but now even the data was showing a pattern that if age less than 20, then there is a slightly different behavior, and greater than 20 but less than 40 has a slightly different behavior. So these thresholds will change, but the same feature can still be leveraged at different depths also. This is the file that got exported. So let me explain you this quickly. So now if you see here, it will clear all your doubts that from that training data, this tree is built. And if you look at this tree, this is the root node. At the root node, the column you are using for splitting is smoker, and the value is 0.5. So if the value is less than 0.5 means non-smoker. If value is greater than 0.5 goes towards smoker, right? Because encoded value was between 0 and 1. So going here means non-smoker, going here is smoker. Further, if you look at the samples 935, total 935 records were there in my data set. Now out of 935, you will see 744 came here, 191 came here based on this split. And further, here the split is happening on BMI, and here the split is happening on age. So here the split criteria at the child is different. And then based on that, there is BMI and age. And you will see what I was saying. See, age is again taking part in the split at the next level. So if I show you, this is how this tree looks like.